Welcome to your CCPS Science Review Lab. Let's take a look at today's topic. When you look at our picture below, who do you think is going to win the tug of war and why? Well, part of me feels like this could go either way. On the one hand, we have more people pulling on this side, but these folks over here are a whole lot bigger. So which one do you think is going to put more force upon the rope? Well, what I can tell you is that in order for someone to win, the forces have to be unbalanced. Well, what does that mean? Let's review. Okay. When we have balanced forces, that means we have the same amount of pull going in this direction as we do in this direction. We have no acceleration. That means nobody goes anywhere. So if we go back to our original picture, if these guys over here are pulling with the same amount of force as these guys over here, then they're going to stay there for a really long time and no one's going to win. Another example of balanced forces is when we've got this soccer ball just sitting here on the ground, right? We've got gravitational force pulling down and we have normal force resisting. That's the force given off by the soccer ball just by the fact that it sits there and it doesn't get pulled through this surface to the center of Earth. We call that normal force. Okay? Because it's not moving in any direction, we know these forces are balanced. We have no acceleration. Now, we can figure out how this works in everyday life looking at something called a force diagram. Okay? Just bear with me while I review this for you. So, here we've got this soccer ball and it's being kicked by this kiddo right here, right? We know it's going to go in this direction. So, let's apply this idea to this force diagram. Here I've got, let's pretend this square is my soccer ball. Okay, it's getting kicked with 10 newtons of force in this direction. Okay, so maybe there's resistance being put on by the grass or the dirt, whatever it's being kicked on, and that's providing friction. And that's sort of fighting back in this direction, in the opposite direction to the kick. So if we have 10 newtons of force going this way to our right and 2 newtons of force going in the opposite direction, we know that our net force is going to be 8 newtons, 10 take away 2 is 8, going to the right. So our force diagram would result and we would know an 8 newtons of force going to the right. Now let's just go with the idea that all of this is happening directly on the ground, okay? So the soccer ball is rolling on, the soccer ball is rolling on the ground. So we've got 5 newtons of force pulling down. We've got 5 newtons of normal force pushing up. That means that it's not going to either get sunk into the ground or float away. So from that direction, those forces are balanced, right? 5 and 5, the same, pushing in opposite directions, those forces are balanced. So when we're looking at a force diagram, 2 things we really need to focus on are number 1, the direction of the arrows, and number 2, the magnitude or the size of the force. And we use that to figure out what direction and with how much force the object is eventually going to be moved. What I'd like you to do now in your notebook is take a look at these 1, 2, 3, 4 examples. Actually, 1, 2, 3, 4 examples. And go ahead and figure out the net force and the direction of that force on each box. This is your opportunity to show what you know. Good luck.